Alright, let's look at quantization error. Quantization, if we look at the Arduino Uno, there they say it's got 10 bits analog inputs, and it can measure between 0 and 5 volt. So the values are 0 and 1023. That's the 10 bits. So let's just look at the equations just to make this a little bit of maths here. Let's make it a little bit easier. So quantization says this, it's fs divided by 2b minus 1. They streamline it to 2b. I don't like the streamlined version. I like the full version. And so what's going to happen here? If that VF is 5 volts, 0 to 5 volts. So let's go to MathCAD quick. Again, you can use this on a piece of paper. I'm not going to show you MathCAD, but MathCAD is just a nice way to calculate this. You can do this on a piece of paper, as I say, or in Excel, or whatever you use for a mathematical equation. Whatever you do use for your mathematical calculation, sorry. So what do we see here? 10 bits. It's a 10-bit system, so 10 bits would mean, let me just move this a little bit lower here. 10 bits, and then we say 2b, so 2 to the power 10 minus 1 will give us that 1023, and that's where we get the 1023 samples. It means we're going to go from 0 to 1023. 5 volts, we go from 0 to 5 volts, so our range is 5 volts. We use that formula, quantization, so it's 5 divided by 2b minus 1, we get this. So this is the voltage per step. What does voltage per step mean? If I go down here to voltage per step, I just defined a range here. Just go this one down here like so. It means to read the value 0, we need 0 volts. So if we read on the analog pin of the Arduino, if we read on the analog pin 0 volts, it's going to give us a 0. If we read 4.881 millivolts, it's going to give us a binary 1, and this binary 2, and so on. So if we scroll down here up until 1 volt, for instance, roughly 1 volt will give us a certain binary value, and you can calculate that with that equation. So we can a certain binary bit. So to get the best resolution, you must make sure that the input voltage range goes from 0 to 5 volts. So what's my point here? My point here is, if you look at the LM35, we said the LM35, let me just go back here. The LM35 sensor will be, if it's 20 degrees Celsius, it will give you 0.2 volts. If it's 30 degrees Celsius, it will give you 0.3 volts. If it's 100 degrees Celsius, it's going to give you 1 volt. So we're only going from 0 to 1. So if we use this other equation, this calculator, we can see if we only use from 0 to 1, we're not going to use all the bits. So we get a certain step function here. Let me just go back to the sketch here. So it means every time this area, every time we get that voltage, a step size of this voltage, which is 4 millivolts. Let me do this. There we can see we get these steps. Snapping tool. So on our input, we're going to get, every time the voltage increase on our temperature, the input actually reads this. Can you see that? So it's a step size, and that step size is that amount of voltage. So it needs to jump that amount of voltage, which is not completely correct. I'll still show you what actually happens when we calculate it even more. But it means that this voltage is 0. This one is 4,883 millivolts. So we can calculate that back to temperature. If we're only going to go to 1 volt, we can see what temperature increases steps we can do. So we can't measure that center values. So you must make sure that the resolution you want to measure, the temperature steps that you want to measure, actually fits into this sample in this 1000 points. In this case, you only have 1000 points. So you can say if you're going to go from 0 to 100, you only have 1000 points, but you only go to 5 volts. So you even have less than 100. It's that 1023 divide by 5 because it only goes to 1 volt. So what's the option? To get the most resolution, you have to go with the op amp before. A non-inverting op amp, and you have to get the gain. Still remember that gain, it's not covered in this tutorial, but the gain, it's calculated with that resistor and the 1 year, the theory behind it, so that 0 to 1 volt on the input of your non-inverting amplifier is going to give you 0 to 5 volt on the output, and then that gain is going to go with your calibration index as well. So if you go then here, 0 to 1 goes to 0 to 5, you're on the full range in this case of the Arduino Uno. And then that would give you the best resolution, the best steps of temperature that you can, the smallest steps in between. If you only have one step, you only know it's 0 or it's 1 degree Celsius. If your step size were too large and it only goes from 0 to 1 volt, you wouldn't be able to measure the temperatures in between. So this is just something to consider. Sometimes you will have to do inverter, and we call this instrumentation amplifier before, to just amplify it from 0 to 5. If you're happy with your resolution, you can go from 0 to 1 volt, like for the LM35, 0 to 1 volt. We're only going to go from 0 to 0.4 volts. So we're only going from 0 degrees Celsius to 40 degrees Celsius. So you can calculate your range for that. Remember that this is still 5 volt, and we still have 10 bits. So you have to see what is your step size and up until how many bits do you have just to go from 0 to 0.4. So you have to manipulate your mathematics a bit to see what your resolution is. Step size is still this, so we can theoretically say 0.4 divide by that, and we would know what your step size is. So back to the maths. Now this is fine, but remember, when does it switch from bit 0 to bit 1? That is the voltage for bit 1, but it might already switch halfway through. So what we normally do is we take the quantization and we divide it by 2 to get the quantization error. So this means if your voltage is around that point, or your voltage is around point, it might switch to 1 bit lower or 1 bit higher. It might jump up and down on a bit, on a value. So the computer or your machine, your Arduino or your FPGA, is going to read either this, the equivalent bit for this one, or the equivalent bit below it. So this is, you should consider this as well in your step size. Just forget the first one, because that's supposed to be 0 for your first one. From 0 up until 2.4 millivolt, that's going to be where it's going to read 0. Thereafter it's going to start reading 1. It's going to jump to the 1. Then the next thing that you can calculate is your quantization signal to noise ratio, which is done with that formula. So this is the kind of quality of your system. What is really important is your step size. So let's look. The Arduino Uno has got 10 bits, so that's your step size. So again, every increment of that voltage would be a next value that it actually can record. If we look at the Myrio has got a 12-bit range, and the input range is also from 0 to 5 volt for the first part. So 12 bits. So let's see what difference will that do. So instead of 10 bits, it's 12. It's still 0.5. If I do the question now, can you see that it's a much smaller resolution? So the step size, the steps are broken down. The step size is much smaller. So if you want to measure smaller increments of temperature, this would be a better one. There's more values it can measure, it's a better resolution. This physical step size that looks like steps is smaller. So I'm going to show you in the next video just how this will fall into the, we'll just show in the next video how this will fall into the Labview file.